Dividing polynomial expressions and functions. There are three topics we want to discuss in this lesson. Dividing a polynomial by a monomial, use long division to divide by polynomials that are not monomials, and lastly, use synthetic division to divide polynomials. Let's first take a moment to review fractions and long division. Normally, if you look at this fraction, 18 divided by 2, you say the answer is 9. I want you to look at it differently. Look at it in terms of the sum of 10 and 8 gives you 18, which I can now break this down to 10 over 2 plus 8 over 2. 10 divided by 2 is 5. 8 divided by 2 is 4. The answer is 9. Now we knew that at the very beginning, but we're looking at this from this perspective because we'll have problems like this, where you cannot combine there are no like terms, so you cannot combine 10x squared plus 8x squared in the numerator. But you can break this down like I broke this down. Simplifying, 10 divided by 2 is 5, x squared divided by x is x, and then 8 divided by 2 is 4, x divided by x is 1, which gives me 5x plus 4. So if you can remember the quotient property of exponents, if you're dividing powers with the same base, we subtract our exponents. So in other words, when you have the same base and you are dividing powers, the base stays the same and then you subtract your exponents. So for example, x to the 7th divided by x to the 4th is x to the 7 minus 4, or x to the 3rd. To divide polynomial by a monomial is the exact same concept. So this is long division. This is the same problem we just worked. The same problem we just worked, as opposed to it being in fraction form, it is now in long division form. So when you divide, you look at your dividend and then you look at your divisor. You ask yourself, how many times will this divisor go into the first term in your dividend? It's important to remember that when you figure out how many times this divisor will go into this first term in your dividend, the answer must go above its like term. So for example, since 2x goes into 10x squared 5x times, I put the 5x above its like term, 8x. The reason you do that is because once you get to the end, you know you're finished with your problem. And then the rest of it is just long division. And remember, long division is a cycle. First, you ask how many times will the number go in. Secondly, you multiply. Third, you subtract. And fourth, we bring down. And then the cycle starts all over again. How many times will 2x go into 8x? 4. You multiply, 4 times 2x, 8x. You subtract, you get 0, and then you bring down. Since 0, there's nothing to bring down with 0, my answer is just 5x plus 4. In this division problem, notice in my dividend, I have 15x to the 4th, but I have 0x to the 3rds, then 9x squared, then 0x, and then 0 as my constant. I must put those place fillers in if they're missing in my dividend. It doesn't change the value because this says I have 0x to the 3rds, 0 x's, and 0. But we need those place fillers. So first, we ask ourselves, how many times will 3x squared go into 15x to the 4th? Since that answer is 5x squared, it must go above the 9x squared. Then we multiply, subtract, bring down, and we start the cycle all over again. How many times will 3x squared go into 0, x to the third? 0 x's. And then we multiply, we subtract, and we bring down. How many times will 3x squared go into 9x squared? 3. We multiply, we subtract, and we bring down. Since we're at the end of our polynomial, you know you are finished. You can bring down 0 and 0, but you will just end up with plus 0 plus 0. And there's our answer. Now what if your divisor is a binomial? If your divisor is a binomial, what we're going to focus on is our first term of the divisor. The rest of the binomial will come into play when we multiply. So let's look at some examples. The first example I will do for you. The second example, I want you to pause the video and work these yourselves. So first, let's focus on the first term of the divisor. How many times will x go into 5x squared? 5x. And I need to make sure that my 5x goes above its like term. Then I multiply. Now when I multiply 5x times x, I have 5x squared, and then 5x times a 5. This is when the other term in the divisor comes in. And then subtract. And there's my answer, 5x. So please pause the video and try to work these. Remember, focusing on the first term here and the first term here. Okay. So now x goes into x squared. And it goes above my like term. And then let's multiply, subtract, bring down, and ask again, how many times will x go into negative 2x? Negative 2. Multiply, subtract, nothing to bring down, 0 is my remainder, x minus 2. The last one. Check your work. Make sure that you have the same information. And right here, notice, this is 6x minus negative x, which gives me a positive 7x. Bring down your negative 7. X goes into 7x 7 times. Subtract. And there's my answer, x plus 7. So what happens if there's a remainder? So we've only worked problems that had no remainder. You do the exact same thing, except for the end, there's a slight adjustment. So first, 2x goes into 4x squared 2x times. Multiply, subtract, bring down. 2x goes into 3x 1 time. You multiply, subtract, bring down. 2x does not go into x. So since 2x cannot go into x, I'm left with a remainder of x plus 5. My math lab will not allow you to write the word remainder in, so you must write it like this. 2x plus 1, there's my answer, plus the remainder divided by the divisor. Please take a moment, pause the video, and try to work this problem. Remember, we focus on the first term of the divisor. Subtract. Bring down. X goes into 5x 5 times. Multiply. Subtract. I have a remainder of 3. But I can't write it like this in my math lab, so I need to write it as my answer, x plus 5 plus 3 over my divisor. Synthetic division. Synthetic division is not mandatory. Some people really enjoy synthetic division and others do not. The one thing about synthetic division is it can only be done when you have a divisor that is a binomial and the coefficient of the leading coefficient of the binomial is 1. So in this case, my divisor is a binomial and the leading coefficient here is 1. So for synthetic division, we care about the coefficients of the dividend and we care about the opposite number here. So in this case, I care about 1, 6, -7, and then I also care about the opposite of -1, which is +1. So let me show you how we set this up. First, list the coefficients. Secondly, I care about the opposite of -1, which is +1. Now, in this case, once you have this set up, there are only 2 operations we're going to do. We're going to multiply and we're going to divide. And it's all single digit, maybe sometimes double digit multiplication or addition. So, step 1 is you always bring down this first term. And then we multiply, add, and we keep going on with the multiply, add cycle until we are finished. So the first step is multiply. 1 times 1 is 1, and it goes here. Then I add 6 plus 1, 7. Then I multiply 1 times 7, and that goes there, 7. And then I add, and I have 0. Now, interpreting what this means, your very last slot is your remainder. Your next slot is your constant, and the slot before that is your x term. So this should be 1x plus 7 with no remainder. Let's try another one. I want you to work this problem, so please pause the video and try to work this problem yourselves. Remember, there are place fillers that are needed. So I have 1x to the third plus 0x squared plus 0x minus 8. And then remember also, on the outside of the line, I have the opposite of this. So please pause the video. Okay. So we have our 2 on the outside, and we have our x to the third, 0x squared, 0x minus 8. First, bring down, then multiply, add, then multiply 2 times 2, 4, add, then multiply 4 times 2, 8, then add. Remember, remainder constant x squared term, and there's our answer. Please make sure you do the My Math Lab problems out of 5.7. Thank you.